Okay, so in the next part, we want to look at question 5. So what is happening here? If resistors R1, R2, R3 are connected in parallel to make R ohms resistor, the value of R can be found from the equation. Find the partial of partial R with respect to R2. Okay, so here they're giving us values for R1. R1 is 30. When R1 is 30, R2 is 45, and R3 is 90 ohms. So all these are in ohms. Okay, so how do we approach this? Well, it's the same concept really. Getting partial derivatives. Understanding what will be the variable, what will be constant, and so on. So this is question 5. So you can operate it the way it is, but it looks a little bit messy. I would want to make R the subject of the formula if it is possible, but you can still approach it with just the way it is. It still works out. Even the way it is, it can still work out. Okay, so how do we do it? So here I can make a single fraction. I want to see which one would be more easy doing the way it is. Looks like it might be the better choice here. But let's avoid implicit differentiation and make R subject of the formula. So to make R subject of the formula, first I'll make the right hand side a single fraction. So single fraction, what will be there? Common denominator will be the product of R1, R2, R3. And then when I start crossing here, for the first part, R2 and R3 will show up. So again, you can make it single fraction your own way. I'm trying to take shortcuts here. R1 and R3 would remain here. Then R1 and R2 would remain here. So a single fraction would look like this. Then of course here, I can now make invert it so that R goes on top. This would now be R1, R2, R3 divided by R2, R3 plus R1, R2, R3 plus R1, R2. So this is what I have now. So if I now wanted to get partial R, partial R2, all you have to see is the variable appears here and it also appears in the denominator. So I have a fraction here. I have two functions, one function on top, one function down. So by avoiding implicit differentiation in the previous case, as in when the functions were different fractions, by making it a single fraction, I've ended up with having to differentiate by quotient rule. In quotient rule, we look at two functions, one u on top and the other one v down. And it follows that to differentiate these, what do? You can keep v, differentiate u, minus, now keep u, differentiate v, then divided by the square of v. So this is what we're going to follow. So how are we going to do it? So first, identify what u is. U is the numerator. So our numerator, u, will be equal to R1, R2, R3. And our v, the denominator, will be R2, R3, R1, R3, R1, R2. But because we're doing this with respect to R2, even when differentiating u and v, it will be with respect to R2. So R2 is the variable. R1 and R3 are constants. So the derivative of u with respect to R2 has power 1, so it reduced to just 1 altogether. So this will remain R1 and R3. Here, v, when I differentiate this one does have R2 and it has power 1. So here only R3 will remain. This one does not have R2, so it is a constant. Since it doesn't, with respect to R2, it is a constant. So its derivative there will be 0. The third one here does have R2, so it will be plus R1. The derivative of R2 there will just be 1, so it will remain like this. This will be our V prime. By quotient rule, first we'll keep V the way it is, meaning R2, R3, plus R1, R3, plus R1, R2. All this is just V. Then we'll multiply it with U prime reduced to this, which is R1, R3. Then minus U. U is R1, 2, 3. So U is R1, R2, R3. Multiplying V prime reduced to this, R1 plus R3. Then all this divided by V squared. And V squared, V is this one here. So V squared will be R2, R3, R1, R3, R1, R2. But remember, V squared, so a square there. So there we have it. We have obtained the derivative, the partial derivative. But here, they have given us the values of R1, 2, and 3. So want us to get the specific value. So all you have to do now is get the values they gave. They gave the value for R1, R2, and R3. So all you have to do now is get these values and plug them into the expression. So you can get this and plug it where we have R1, put 30. So 30 comes here, 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 and there. Where we have R2, which will be here, there, and finally there. And where we have R3, you'd put 90. And there we're done. So after substituting, simplify, and of course you're going to get the answer that they want.